Welcome to another episode of Math with Mrs. Wilson. This is section 9.6, Graph Quadratic Functions Using Properties. By the end of this section, you will be able to recognize the graph of a quadratic function, find the axis of symmetry and vertex of a parabola, find the intercepts of a parabola, graph quadratic functions using properties, and solve maximum and minimum applications. For this first example, it's asking us to graph using a table of values. So we are going to plug in values for x and get an output of f of x using the function that they give us. So let's plug in a few values, maybe -2, 0, 1, +2, and see what we get. So we have negative, parentheses, -2 squared. That comes out as -4. When we plug in 0, we get 0. When we plug in 1, we get -1. And when we plug in 2, we get -4. Now we're going to graph these on our graph. Zero, 0, 1, -1, 2, -4. You can see it's symmetrical about 0, 0. So this is our graph. I'm going to pause the video and have you do B in your groups on the whiteboards. So check your parabola. If you're not sure, then go ahead and look at each of the inputs that I put in. Your inputs may be different, and that would give you different points, but the shape of your parabola should be the same. Remember that parabolas can open upward or downward, and that's based on if the a is positive or negative. So if a is greater than 0, would mean that the number in front of x squared is positive, then it opens upward. If a is negative, then the parabola opens downward. That's all that box is saying. So turn your page when you're ready. This next concept is pretty important. We learned that we could find the vertex by putting the standard form of the equation into vertex form. There's another way that you can do that, and that's by finding the axis of symmetry. The axis of symmetry is found by using b over 2a, or -b over 2a. And then you plug whatever number that is. That's the x-coordinate. You substitute this into x and solve for f of x. That gives us the y-coordinate. Let's apply that concept right now. For the graph of f of x equals 2x squared minus 8x plus 1, find the axis of symmetry and the vertex. All right, we are going to use the axis of symmetry formula. X equals -b over 2a. Plugging into that, we have -8 over 2 times 2. That's from our a, which is 2, and our b, which is -8. So -b over 2a. This simplifies to 8 over 4, which is just 2. X equals 2. That is our axis of symmetry, so part A. And we'll just label it as AOS, axis of symmetry. Now we're going to plug that in to the function to find the vertex. We have f of x, but instead we're plugging in 2. F of 2 is equal to 2 parentheses 2 squared minus 8 parentheses 2 plus 1, because we're just plugging it into this equation or this function. All right, so f at 2 is equal to, simplifying this, we're going to do exponents first. 2 squared is 4. 4 times 2 is 8. Minus 8 times 2 is 16. Plus 1. Negative 8 plus 1 is negative 7. So f of 2 is equal to negative 7. And we just write that. The vertex is 2 comma negative 7. Right, we will pause the video here and let you work on the whiteboards for the next example. Check your answers before we move on. In this next section, we're being asked to find the intercepts of a parabola from the standard form of a quadratic equation. Well, remember when we were trying to figure out the y-intercept? The y-intercept is when the x value is 0. So to find the y-intercept, we substitute x equals 0 into the function. And the x-intercept results when the value of f of x is 0 also. And we found that by factoring or the quadratic equation or completing the square, anything that we can do to figure out what x equals. So to find an x-intercept, we let f of x equal 0. In other words, we need to solve the equation 0 equals ax squared plus bx plus c for x using any method that works for you. Could be factoring, could be the quadratic formula, could be completing the square. So let's practice this. Find the intercepts of the parabola whose function is f of x equals x squared plus 2x minus 8. You can easily see that the y-intercept is 8, or negative 8, I'm sorry. So the y-intercept, if you plug in 0 to x, you get negative 8. Can we factor this? Yes, we can. Factors of negative 8 are 4 and negative 2. Those are the factors, and when we subtract those, we get 2. So our factoring of that, we'll just rewrite this, x squared plus 2x minus 8 equals 0, because we have f of x is equal to 0. When we factor that, we get x minus 2 and x plus 4. Using the zero product property, x equals 2 and x equals negative 4. Using the two x-intercepts, these are now x-intercepts, 2 and negative 4, and we use the y-intercept, 0, negative 8, we can kind of see how this is going to mirror, except that the mirror image to that one would be here. So it comes down like this. The flaw in graphing like this is we don't know the vertex. We could figure that out, though I think we should, just to double check. It makes our graph look much better if we do the vertex. So the axis of symmetry is negative b over 2a. So negative 2 over 2 times 1 is just 2. So the axis of symmetry is negative 1, and I kind of guessed that. So axis of symmetry is this line. It's like our mirror. And if we plug negative 1 into the equation, f of x, this is to find the vertex, instead of f of x, we're going to plug in negative 1. So negative 1 squared plus 2 times negative 1 minus 8. Negative 1 squared is 1. Minus 2 minus 8. That is going to equal negative 9. So f at -1 is -9. I was pretty close, except it's right here. I went a little low on my graph. But I did kind of guess that symmetrical point there. Turn your page when you are ready. On this page, you are asked to find the intercepts. You can find the intercepts if you have time. You could also figure out the axis of symmetry. So work on finding the y-intercept and the x-intercepts. And if you have time, you can find the axis of symmetry and the vertex to be able to graph it. I'm going to pause the video and you can get started. You can check your answers, making sure that you for sure got these points on your graph. I couldn't graph the vertex because it was off the graph, so you can see that my parabola is not fully showing here. Right. This is a note that the solutions of the quadratic function are the x values of the x-intercepts. So these are the solutions when you solve a quadratic. Here are the steps to graphing a quadratic using properties. The first thing that we want to determine is if it opens upward or downward. Since a is positive, the number in front of the x squared, see there's no number, it's just 1, so it's positive, opens upward, like this. The next thing we do is we find the axis of symmetry, so we look at -b/2a. In this case, b is 2 and a is 1, so this simplifies to -1. X equals -1, that's a line, it's a vertical line. Then we plug that in to figure out the vertex. So f at -1 is equal to -1 squared plus 2 times -1 minus 8. That's going to be 1 minus 2 minus 8, which is -9. So f at -1 is equal to -9. And so the vertex is -1 comma -9. These are the important features of the properties. Find the y-intercept. We find the y-intercept by plugging in 0 to x. So the y-intercept is 0 comma -8. We're going to use all of this information to graph. And then we find the x-intercepts if they exist, which means they might be imaginary numbers. But I can find factors of -8. Factors of -8 are 4 and 2. So 4 and 2. We're going to make the 2 negative so that, and the 4 positive, so that when they add together, we get the middle term, which is 2. Using the zero product property, x equals -4 and x equals 2. Those are the solutions, and so the intercepts are 2, 0 and -4, 0. This gives us a lot of points that we can now put on our graph. And we know that it opens upward. So the first thing that we found in step 2, after we found out that it opened upward, was that the axis of symmetry is -1. So that's our mirror. We reflect over that. And our vertex is -1, -9, which is here. Our y-intercept is 0, -8, right here. Our x-intercepts are 2 and -4. and our intercepts are equidistant from the axis of symmetry because it makes a mirror. When you're ready, turn the page. On this example, we're looking to graph by using properties. Again, the first thing that we look for is whether the parabola will open up or down, and in this case it opens up downward because the A was -3, and that would make it downward. The next thing that we're going to look for is the axis of symmetry, which is a line, and that formula that we use is x equals -b over 2a. On the axis would be x equals -b would be -12 over 2 times a, which is -3. That's -12 over -6, which is just 2. So the axis of symmetry is x equals 2. Now we use the axis of symmetry to find the vertex, and we find the vertex by plugging in 2 into the x. So f of 2 is equal to -3 parentheses 2 squared plus 12 times 2 minus 12. So f of 2, if we simplify this, is equal to -3 times 4 is 12 plus 24 minus 12, that equals 0. So our vertex is 2, 0. All right, so now we have the axis of symmetry. We know it opens up where it opens downward. And now we're going to look for the x-intercepts, but I think we're only going to have one x-intercept, and it's going to be the vertex. You'll see why in a moment. This is factorable, so instead I'm going to rewrite this. If f of x is 0, I'm going to rewrite this by dividing everything by -3, so we end up with x squared minus 4x plus 4. If we divide each piece by 3, or -3, then this factors to be x minus 2. It's a perfect square trinomial. So when f of x is 0, x would have to equal 2, using the zero product rule. But we already had an x equals 2. That was our axis of symmetry. So the only y-intercept is the only x-intercept is 2, 0. So that was finding x-intercepts, which we only had one. Then we also want to find our y-intercept. Kind of did that out of order. I normally would do the y-intercept first. The y-intercept, if I plug in 0 for x, we get -12. Now we have enough information to be able to graph this. Let's draw a graph and put our x-intercept at 2 along with our axis of symmetry, and our y-intercept at -12. And then that point is going to mirror image over our axis of symmetry. So there's a third point which helps us graph our parabola. All right, I'm going to pause the video and allow you to try the next one. This one. Now that you've checked your work, I would like you to work in your groups on this next one as well, and then come back to check your answers. Check your work and correct it before moving on. On this one it was a little tricky. We had to use the quadratic formula to be able to find the x-intercepts. Okay, one last example. Applications of minimum and maximum. The quadratic function h of t equals negative 16 t squared plus 128 plus 32 is used to find the height of a stone thrown upward from a height of 32 feet at a rate of 128 feet per second. And you can see those values in the function. How long will it take for the stone to reach its maximum height? What is the maximum height? So how long will it take? And so the maximum height is going to be the vertex. And we can graph this to show that, and we can just find the vertex. So first let's find the axis of symmetry. That's going to be negative b over 2a, which in this case is negative 128 over 2 times negative 16. So that's 128 over 32. That reduces, let's see, I think it goes in evenly. Let me double check on my calculator. 128 divided by 32 is, yeah, it's 4. That's what I thought. Guess I could have done that in my head. And then we plug that in to figure out what the vertex is. So what is the height at 4? And since it's the height at 4, 4 is actually seconds. And now we're trying to figure out feet. So we plug in 4. And then we solve. So 4 squared is 16, negative 16 times 16 is 256. 128 times 4 is 512 plus 32. So that simplifies to be 288 feet. Alright, so how long will it take? It will take 4 seconds, and the maximum height would be 288 feet. You could graph this. They're in decimals or your graphing calculator. And our y-intercept is 32, but we have to go all the way to 288 feet. So let's count by maybe 25s. So that would be 100. This would be 200. This would be 300. So we counted by 25s, but I only marked the hundreds. And then we have 4 seconds. So we'll just count by ones here. So our x-axis is seconds, and our y-axis is feet. At 4 seconds, we're at 288 feet. Our y-intercept is 32, so about here, because that's what you're throwing it from. You're throwing the stone upwards. And it will come back down here. 1, 2, 3, 4. Also 4 ways, so at 8 feet it'll be back at 32. And you could do some math to figure out the x-intercept to figure out when it lands on the ground. And that completes our notes for today. Don't forget to write a summary and to get your homework paper ready.